Late 1943. Somewhere in the Pacific, a storm tears across the island, the kind that bends palm trees like blades of grass. Sheets of rain hammer the coastline, turning red-brown soil into thick, sucking mud. The wind howls through the coconut groves, driving salt spray far inland. Inside a curved hut of corrugated steel, a dozen Allied soldiers crouch in silence. The walls groan but hold firm. A single lantern flickers, casting thin shadows across rifles stacked in the corner. Outside, the camp is chaos. Tents ripped apart, crates floating in puddles, equipment buried under sand. But the hut stands unmoved. Its arched ribs flex with the wind, dispersing the pressure across its frame. Rainwater streams harmlessly down its curved sides, pooling around the base. Within, the air is damp but safe, a rare comfort in a world swallowed by war. To these men, it is just another night survived. But to the engineers who designed it, this moment is proof of something extraordinary, that simplicity could endure where complexity failed. This was not a bunker, nor a barrack in the traditional sense. It was a Quonset hut, and it would soon become one of World War II's unsung engineering triumphs. When the United States was thrust into war after Pearl Harbor, December 7, 1941, it faced a logistical nightmare unlike any in its history. Within months, the U.S. Navy had to expand from a coastal defense force into a global oceanic armada, one that would need bases, depots, workshops, and living quarters across 2 oceans and every climate on Earth. But the Navy's greatest weakness wasn't firepower. It was infrastructure. Wherever Marines landed, there were no barracks, no hospitals, no offices, only jungle, mud, and coral. And every hour lost waiting for construction was an hour the enemy gained. The Pacific was not kind to builders. Timber rotted, steel corroded, and the humid air devoured anything not designed to last. Conventional wooden barracks took weeks to raise. Poured concrete needed materials, and time no one could spare. What the Navy needed was a structure that could be shipped anywhere, assembled by anyone, and survive anything. This urgency led to the creation of one of the most remarkable engineering units of the war, the Naval Construction Battalions, better known as the Seabees. Formed in early 1942, the Seabees were a unique blend of soldier and builder, men who could swing a hammer one minute and fire a rifle the next. Their mission was clear. Wherever the Navy went, the Seabees would go first, to carve bases out of nothing. But even these resourceful men needed something to work with. A building system light enough for transport, strong enough for battle zones, and simple enough for untrained hands. The Navy called on architects, engineers, and manufacturers to answer that challenge. The result would begin as a sketch, a semicircular design inspired by an earlier British invention. But before it could transform into the shelter that would dot every battlefield from Guadalcanal to Normandy, it first had to pass through an unassuming airfield on the coast of Rhode Island, a place called Quonset Point, where an idea would turn into an icon. The solution, as it turned out, had roots in another war. During World War I, British engineer Major Peter Neeson had designed a portable, semi-cylindrical steel hut, the Idihai Neeson hut, to shelter soldiers on the muddy battlefields of France. It was cheap, easy to transport, and could be assembled in hours. By 1941, the U.S. Navy saw in that old British design the seed of something far greater, something that could be reborn for a new kind of global war. In the months following, Pearl Harbor, the Navy's Bureau of Yards and Docks, gathered a team of engineers and architects from across the country. Their task: create a building that could be mass-produced, packed flat, shipped overseas, and assembled without skilled labor. Every bolt, beam, and panel had to fit inside a standard cargo ship hold, and every piece had to serve a clear purpose. The team set up operations at Quonset Point Naval Air Station in Rhode Island, a quiet coastal base that would soon become the birthplace of one of the war's greatest engineering exports. From that location came the name that would endure, the Quonset hut. The Americans improved on the old Nissen design in every way. They replaced the narrow British steel sheets with wider, corrugated galvanized steel, more resistant to rust and damage. The internal framing was simplified into lightweight arched ribs, making it possible to erect a hut in a single day with just a few men and hand tools. Ventilation flaps were added for tropical air, insulation for colder climates, and end walls could be adapted: wood, steel, or canvas, depending on what was available. The structure's semicircular shape wasn't just for aesthetics. It distributed stress evenly, resisting wind and even nearby blast waves. By early 1942, the first prototypes stood gleaming in the Rhode Island sun. The Navy approved mass production almost immediately. Assembly lines began churning out kits, each one containing every nut, bolt, and beam needed to build a complete hut. Within months, thousands of Quonset huts were being loaded onto Liberty ships and sent to the farthest corners of the globe. From frozen Aleutian outposts to malaria-ridden Pacific islands, they became workshops, mess halls, hospitals, and homes, proving that in war, true strength often lies in simplicity. What began as a sketch at Quonset Point was now a vital instrument of the Allied advance, an invention not built for glory, but for survival. And as the huts spread across the world, so did the stories of the men who built and lived in them. Engineering angle. The brilliance of the Quonset hut lay not in its materials, but in its geometry. The arch, one of the oldest structural shapes in human history, became the foundation of a wartime innovation. The curved frame distributed stress evenly across its surface, eliminating weak points and reducing the need for heavy internal supports. When high winds or pressure waves from nearby explosions struck the hut, the force didn't batter one side. It flowed smoothly across the arc and down into the ground. This made the Quonset hut an engineering paradox: light yet incredibly strong. Its corrugated steel skin acted like a spring, flexible enough to absorb impact, rigid enough to withstand weight. Even when anchored in mud or sand, the hut's shape allowed it to survive where traditional buildings would splinter. Soldiers often said the wind rolled off the Quonset, just as waves rolled over the sea. Production, angle engineering genius alone wouldn't win a war. Production would. In 1942, once the design was finalized, the U.S. Navy contracted major manufacturers, including George A. Fuller Company and Strand Steel Division of Great Lakes, steel to produce the huts at an industrial scale. What followed was an unprecedented mobilization of American industry. Factories retooled within weeks, converting from peacetime products to round-the-clock hut production. The Quonset design was modular and standardized, all components interchangeable, all panels pre-drilled and ready for rapid assembly. By the war's peak, factories were producing as many as 500 huts per day. Assembly lines resembled aircraft production floors, steel ribs rolling in on conveyor belts, being bolted, packed, and shipped in wooden crates labeled Quonset Hut Unit. Each kit contained everything: bolts, washers, doors, windows, and a detailed instruction manual printed for speed rather than clarity. It was a symbol of American efficiency, a shelter born not just from engineering brilliance, but from the nation's capacity to mass-produce hope. Logistical angle. The genius didn't stop at the factory floor. Each Quonset hut kit could be flat-packed into a compact bundle, small enough to fit inside a standard cargo hold, or be airdropped into remote regions. For the Navy and the Seabees, this was revolutionary. One kit contained about 12,000 pounds of materials, requiring minimal tools to erect. 4 men could assemble a hut in less than a day, sometimes in hours, using nothing more than wrenches, ladders, and teamwork. From Guadalcanal to Iceland, convoys arrived with crates stamped Quonset. Once unloaded, the Seabees would lay the curved ribs, bolt on the steel panels, and raise a building ready for occupancy before sunset. No concrete mixers, no carpenters, no electricity, just steel, sweat, and design perfection. In war, speed was survival, and the Quonset hut made survival portable. Environmental angle-few wartime structures were asked to endure so much. The Quonset hut was shipped into climates that destroyed nearly everything else. In the steaming jungles of the Pacific, the air was thick with salt and humidity, an environment where ordinary steel rusted in weeks. Yet the Quonset's galvanized corrugated skin resisted corrosion far longer, shedding rain and tropical heat alike. In Arctic outposts, Seabees adapted the huts with insulation, inner plywood walls, and oil stoves. Snow slid off their curved roofs rather than piling up and collapsing them, an advantage over flat-roofed barracks. In desert regions, sandstorms scoured bases daily, but the rounded frame offered little resistance to the wind, minimizing damage. From the frozen Aleutians to sweltering Guadalcanal, these huts became the universal answer to nature's extremes. Engineers had designed not just a building, but a survival system, one that conquered every climate it met. Human angle for the people who lived and worked inside them, the Quonset hut meant more than shelter. It meant normalcy. Inside those corrugated walls, surgeons operated on the wounded, clerks typed orders, and pilots briefed missions. Nurses hung mosquito nets and decorated walls with photos from home. Engineers turned huts into workshops, filled with the smell of oil and steel. Each hut echoed with human life, laughter, exhaustion, arguments, and silence. Soldiers gave them nicknames like tin can homes or half moons. Some despised the heat trapped inside. Others called them the safest place in a storm. They weren't luxurious, but they were dependable, a rare constant in a war defined by chaos. Enemy angle. Even the Axis forces took notice. When Allied troops advanced through former Japanese and German positions, they often found captured Quonset huts still standing, reused by the enemy as barracks or storage. In North Africa and later Italy, German engineers examined the design closely. Reports from Allied intelligence noted that some Axis camps had begun constructing similar semicircular huts, a clear nod to the efficiency of the American original. What began as an emergency wartime solution had become a universal language of military architecture, respected even by those it was designed to defeat. As the huts multiplied across continents, they formed the silent backbone of the Allied war effort. Yet, their true test and their most dramatic proving ground would come in the brutal campaigns of the mid-war years. From the beaches of Tarawa to the jungles of New Guinea, these steel arcs would shelter the men who built victory itself. By mid-1943, the Pacific War had become a grinding test of endurance. From the jungles of Guadalcanal to the blood-soaked sands of Tarawa, every island was a battlefield carved out of impossible terrain. The U.S. Navy and Marines were advancing, but each victory brought a new challenge: how to transform captured islands into functioning bases capable of fueling the next leap forward. Here, the Quonset hut became as vital as any weapon or vehicle. On Guadalcanal, Seabees worked day and night under enemy fire, raising rows of curved steel huts where nothing but swamp and palm once stood. Within days, field hospitals appeared, their rounded silhouettes glowing under makeshift electric lights. Inside, doctors fought to save lives while artillery thundered in the distance. At Tarawa, where coral dust filled the air and the heat could boil paint from metal, Quonsets rose over the wreckage. Commanders held briefings inside them, maps spread across wooden tables still wet from rain. Radio operators ran cables through the walls, transforming the huts into the nerve centers of island warfare. By Saipan and the Marianas, entire tent cities had been replaced by forests of Quonset shells, each one identical, each one essential. Mess halls, ammunition depots, repair shops, offices, chapels, all made from the same curved kit that had once been an engineer's sketch. The huts allowed the Allies to establish instant permanence in places where permanence seemed impossible. Soldiers slept under steel rather than canvas. Supplies stayed dry. Machines kept running. The curved architecture became a psychological anchor, a sign that civilization, however temporary, had returned to the front. In the chaos of war, they became home. And as the Pacific offensive gained speed, from New Guinea to the Philippines, the Quonset hut followed, multiplying like a signature of American resolve. Wherever the Seabees landed, the huts rose behind them, gleaming in the tropical sun like half-buried moons. By the time the Allies reached the Marianas in late 1944, entire cities of steel arcs dotted the horizon. From above, reconnaissance pilots mistook them for storage tanks or aircraft hangars. They were neither. They were proof that engineering could build victory as surely as strategy could plan it. The Pacific was no longer a wilderness. It was now a chain of strongholds, each one curved, corrugated, and unstoppable. As the war raged across two hemispheres, the Quonset hut followed, crossing oceans, battlefronts, and climates. By mid-1944, the same steel shells that dotted the Pacific began appearing in Europe, where Allied forces prepared for the greatest invasion in history: Normandy. On the beaches of northern France, amid wrecked landing craft and burned-out tanks, the first huts rose within days of D-Day. Seabees and Army engineers unloaded crates marked U.S. Navy Quonset and began bolting together command posts just yards from the surf. Under the cold Atlantic rain, their curved roofs gleamed, practical, defiant, enduring. Behind the front lines, these huts became lifelines. Mechanics repaired Sherman tanks beneath their arches. Doctors treated the wounded in makeshift field hospitals that smelled of antiseptic and wet earth. Radio operators tapped out orders that guided the advance inland. For many soldiers, the hum of rain on corrugated steel became the sound of safety. At the same time, halfway around the world, the Pacific Front was entering its deadliest phase. On Iwo Jima and Okinawa, where entire divisions fought for yards of ground, Quonset huts appeared again, this time built over shattered coral and blasted rock. Their walls bore the scars of shrapnel and bullet holes, yet they stood. Inside, men wrote letters home, generals planned assaults, and corpsmen laid out stretchers in rows. The huts sheltered everyone, generals and privates, nurses and mechanics, and later, prisoners of war. In some camps, captured Japanese soldiers slept inside the same curved walls once raised by their enemies, a quiet testament to the neutrality of design. The hut did not care who it served. It existed only to protect. From the beaches of Normandy to the jungles of Burma, from Alaskan airfields to desert depots in North Africa, the Quonset hut became a constant, a global thread stitching together the vast machinery of Allied war. By 1945, more than 150,000 huts stood across every theater of operation. They had survived storms, shell fire, and years of relentless use. The men inside them had changed, but the huts remained, dented, rusted, reliable. As the final battles ended and victory loomed, these curved silhouettes stood quietly in the background of history's photographs. Behind the flags, behind the parades, behind the headlines. They were never meant to be iconic. Yet they became so silent witnesses to both triumph and tragedy, symbols of a war built as much by engineers as by soldiers. When the guns finally fell silent in 1945, the world was littered with the remains of war: twisted vehicles, empty airfields, and tens of thousands of Quonset huts standing silently in the aftermath. But unlike the weapons and tanks, the huts didn't become scrap. They were too valuable, too practical, and too symbolic of resilience to discard. Across the bombed-out landscapes of Europe and Asia, Allied forces left behind a new kind of inheritance: curved steel shelters that could be repurposed for peace. In war-torn Italy, France, and the Philippines, civilians moved into abandoned Quonsets, patching bullet holes and sealing gaps with wood or tar. The same structures that had housed soldiers now sheltered families, refugees, and students. What began as military architecture became a humanitarian lifeline. In Japan, under Allied occupation, Quonsets served as administrative buildings, classrooms, and hospitals. In Britain, they became temporary housing for displaced citizens, while in the United States, a wave of returning veterans faced an unexpected crisis: a shortage of affordable homes. The government's answer was already waiting in surplus yards: tens of thousands of Quonset huts. Across college campuses and small towns, they were reassembled into student dormitories, community centers, churches, and small businesses. Rows of silver half-moons appeared on the outskirts of cities. Modest, functional, and strangely familiar. They earned nicknames again: Victory Homes, Tin Towns, Veterans Villages. Families decorated them with curtains, flower boxes, and painted doors. Beneath their industrial skin, life resumed. Laughter replacing gunfire. The clatter of dinner plates replacing the rattle of machine tools. For a brief post-war generation, the Quonset hut became the architecture of rebuilding. It symbolized a world trying to stand again. Not in marble or stone, but in corrugated steel and hope. The same design that had protected soldiers from bombs now sheltered their children from rain. Peace Attent feeds. End of World War II. II did not end the story of the Quonset hut. It merely began a new chapter. What had been born from necessity soon became a foundation for architectural innovation. Across the United States, the post-war construction boom drew inspiration from the Quonset's simplicity and modular strength. Architects studied its prefabricated system, lightweight, low-cost, and quick to assemble, and began adapting its principles for civilian life. Companies like Strand Steel, Armco, and Pacific Houses launched their own lines of semi-cylindrical homes, advertising them as modern living for the modern world. These new designs reflected a changing society, one that valued mobility, efficiency, and adaptability. In rural areas, farmers turned surplus huts into barns and storage sheds. On university campuses, veterans attending school under the GI Bill lived in entire Quonset villages. Even churches, libraries, and civic halls rose beneath the same steel arcs that had once served at Saipan and Okinawa. Beyond America, the Quonset's influence stretched to the most remote and extreme environments. In the Arctic and Antarctic, research teams found that the curved steel form performed better than traditional wooden structures under snow load and high winds. The U.S. military continued to use evolved versions in Korea and Vietnam, where super Quonsets provided stronger insulation and improved airflow. Its legacy also shaped the modern world's fascination with prefabrication, the idea that entire buildings could be designed, manufactured, and shipped in pieces. This philosophy lives on in today's modular housing, emergency shelters, and disaster relief architecture, where speed and strength are essential. Even 21st-century designs, from arched aircraft hangars to portable medical units, carry the DNA of the Quonset hut. Over time, Many of the originals rusted away or were replaced by concrete and glass. Yet thousands still stand, quietly, defiantly, in small towns, military depots, and forgotten airfields across the world. Some have been transformed into art studios or cafes, others preserved as historic relics. The Quonset hut remains what it always was, a shape of survival, born from war, reborn for peace. In the end, the Quonset hut is more than just corrugated steel bent into an arch. It is a reminder that even amid destruction, humanity finds ways to build. When engineers at Quonset Point first sketched its curve, they weren't designing a weapon. They were designing shelter, a form that could rise from nothing, protect those who served, and endure through the chaos of war. In its simplicity lay its brilliance. A few sheets of steel, a few bolts, and the promise of safety. That promise traveled across oceans and continents, from the jungles of the Pacific to the snows of Europe. It shielded medics saving lives, mechanics repairing machines, and officers planning battles. Wherever it stood, it turned wilderness into civilization, if only for a while. And when the war ended, its story did not. The same design that sheltered soldiers went on to shelter families, students, and dreamers. The arc of its roof, born from conflict, became a quiet symbol of adaptability, proof that ingenuity can outlast destruction. In the sweep of history, the Quonset hut stands as a paradox of war, a creation meant for survival, not conquest. It reminds us that sometimes the greatest victories of humankind are not in what we destroy, but in what we build to endure.